you switch it.
I could be wrong.
Just look real quick.
Really funny.
Warning.
Okay, right guys. What do you do with the marker?
I think he's trying to say something.
You saved me, bro.
It's right there, right there, right there.
Maybe if your desk was cleaner, it would help.
Don't judge. Okay.
It looks like a horror comment.
Yes, you guys still have your quiz tomorrow.
You can put anything.
What? Anything on the note card?
Anything you want in your note card for tomorrow. Okay. Alright,
Game on.
what these equations describe is light passing through two or more slits, like two or more small openings, and they form what's called a diffraction pattern on like a screen over here. So in the dead center there'll be the brightest spot, then there'll be a dark spot, like where there's no, like if it was a laser pointer where there's no laser shining, and another bright spot, dark spot, bright spot, dark spot, bright spot, dark spot, going in both directions. And the spots get slightly more faded as you get further away from this, what's called the central maximum. So in that equation, the distance between the two slits is d. Does that make sense? So d is the distance between the two slits. Theta is the angle from whichever one of these you're measuring to the central one or the central maximum, so that's theta. And wavelength is the wavelength of the light that's passing through. And then m is the bright spot you're at for the first equation. So for this one it'd be m equals 1, m equals 2, m equals 3. And if you look at like the first thing, those are like this would be the first order bright fringe, this would be the second order bright fringe, this would be the third order. So it's just like, that's just how it's said. There's 1, 2, and 3. So that's for the first equation is to the bright spots. The other possibility is we can measure from here to the dark spots and that angle. Does that make sense? And for the dark spots, the first order one is m equals 0 instead. Second order is m equals 1. Third order is m equals 2. So for the dark spots, it starts at like first order to be 0, so it's kind of subtracting 1 from it. Does that kind of make sense to everybody? Kyle?
Does it go like -1 for the dark solution?
Like on the other side, it's always just the absolute value, so you can just always do 1. Alright, any other questions about these?
Wait, so in both situations, the very middle one is m equals 0, right? If
you're looking for like for the bright spots m equals 0, actually I shouldn't even put that down to be honest. This is just the central maximum. For the dark spots, the first dark spot is m equals 0. So if it says first order, you're finding the angle to that first dark spot, and you use m is equal to 0. Does that make sense? But it's always measured from this central spot. Right? Do you guys have at least like an idea of conceptually what's going on here? Like you're shining light.
Is D the length or like the spaces between? Or
D is how far the slits are apart.
So just the piece.
So again, you're shining light through these two slits, and because of interference, you guys remember talking about this? Like the light waves go out like this, in circles from it, and in certain spots they add together, and in certain spots they cancel out. Where they cancel out, you get the dark spots. Where they add together, you get the bright spots.
So
Laura?
is this going to be on the quiz tomorrow?
This will be on the quiz tomorrow.
What? Is that in between or on a dark spot?
So these guys, these are the ones that I colored are the bright spots, the other ones are the dark spots. So dark spots are in between the bright spots. Does that make sense?
Wait, this is the M.
Here.
It's opposite.
Yeah, I know. There's
Oh.
Sean.
Okay, so with the m equals 0, m equals 1, can you use by 9 again?
Sure. So for the bright spots, the first order is m equals 1, second order is m equals 2, third order is m equals 3. For the dark spots, like the closest one, the first order is m equals 0, second one is m equals 2, third one is, or m equals 1, third would be m equals 2. Does that make sense? Alright, Any other questions about this? We'll do a couple of these together just so you guys get the hang of it. Right, can I erase this? Alright, number 1. The distance between two slits in a double slit experiment is 0.0022 millimeters. The third order bright fringe, m equals 3, is measured on a screen at an angle of 46 degrees from the central maximum. What is the wavelength? Okay, so we use D. Where'd my good marker go? I just had it.
Do we have to convert the millimeters?
We do have to convert the millimeters. How do you convert millimeters to meters?
Multiply by something.
Divide by 1,000. We do D, or D. I'm supposed to write bigger for this. Guys, help me remember to write bigger.
Right
Right,
bigger.
bigger.
Thank you.
Right bigger. Right smaller. So small nobody can see it. Michael. Right. You forgive me.
Okay, so we're looking for wavelength. What's our distance going to be? Point.
Point.
The
0.022.
Point.
0, 0, 0,
0,
2.2
0.
times 10 to the negative 6.
So 5 zeros in front of that, or you could do, as Chloe said, 2.2 times 10 to the negative 6 might actually be easier. Then we do sine. What's the angle in this case? 46. What mode should your calculator be in?
Degree.
Degrees. What's m going to be?
3.
3. And wavelength is what we're looking for. Yes, Anne.
Do we not do m plus 1?
That's for the dark fringes. So this first equation, do you see how it says third order bright fringe? If you use the second equation, it'll say dark. If it doesn't say anything, use the first equation. So only use the second equation if it says something about a dark fringe. Make sense?
Okay.
So what does lambda equal?
Five 5.28 times 10 to the negative 7.
5.28 times 10 to the negative 7. You can also write that as 528 nanometers. Sometimes you'll see it written.
Do we have to?
I'd accept either meters or nanometers.
Thank you.
All right, questions on that one? Brian,
Are the answers always going to be to the negative 7?
what?
Are the answers like always going to be in nanometers?
For wavelength, they're always going to be like on the order of nanometers.
Alright. So if you don't, you know.
If you get like the wavelength is 2 million meters, you've done something wrong. Can I erase this?
Yeah.
Alright. We're going to do number 2 and then number 4, and then it'll probably be done. Alright, a laser is placed to a diffraction grating that contains 153,927 lines per meter. Illuminates the grating surface with monochromatic light of wavelength 693.3 nanometers. At what angle will the second order maximum appear? This one doesn't say anything about a bright or dark fringe. Just assume if it doesn't say anything that it's going to be bright. Make sense? Okay. Getting D here is slightly tricky, the distance. It gives us how many, the lines per meter is like how many spaces per meter there are. So how many spaces per meter, if we have spaces per meter, how can we get to meters per space?
Wait, what?
1 over. So we're gonna, so to get our distances between the two openings, it's 1 over 153,900.
27.
And what does that equal for the space between two of them?
Times 10 to the negative 6.
6.5 times 10 to the negative 6 meters per line. But really just need the spacing is just 6.5 times 10 to the negative 6.
Yeah, how do you know that it had to be
So it gives us
meters of it?
how many lines per meter.
Uh-huh.
and what we really want is meters per line.
How do we know that we want that?
Well, we want, like, say we have, the black lines are like the spaces here. Say we have, let's say that's 1 centimeter just for a case. If we have 4 spaces, or 4 spaces in 1 centimeter, so this would be 4. How can we find, that's the distance d we're looking for in like the equation.
Yeah.
How can we find the distance between those two?
Okay, you just do 1 over.
Yep.
I just didn't know why we wanted. Okay.
Does that make sense to everybody now?
Do we need to convert wavelength?
We do need to convert wavelength. So it's going to be, lambda is 693.3 nanometers. How do we convert from nanometers to meters? Anybody remember?
10 to the 7 times 10 to the second.
Nanometer, 1 nanometer equals 10 to the negative 9th meters.
Oh, I'm not gonna remember that.
You can write it on your note card.
Okay.
Can you say that again?
Alright, to get from nanometers to meters, we divide by 10 to the 9th. So this ends up equaling 6.933 times 10 to the negative 7th meters. You guys are letting me write small again, aren't you?
It's very big.
Right big, Mr. Sensei.
Right small.
You don't even need us to remind you. You're doing it all by yourself.
I wrote a bunch of stuff small up there already.
Don't cry.
I just wrote the wrong
Just take up the whole board.
6.93 times 10 to the negative 7th meters, which is divided by 10 to the Okay, so I have wavelength. What is our m value going to be here? 2. So we do d sine theta equals m times lambda. Distance is 6.5 times 10 to the negative 6 meters. Times sine, the angle, equals 2 times 6.93 times 10 to the negative 7 meters. So we multiply these, divide by this, then what do we do to get theta?
Inverse.
Inverse sine. So what does theta end up equaling?
12.36 degrees.
12.3 degrees. Ellie?
How come up there, so we got it in
Meters per line?
meters per line, and then we converted meters per line to nanometers?
No. This wavelength here is, like the wavelength we're given is 693.3, like that's in the problem. And we need to convert that to meters as well. So we need everything in meters.
Okay, so we're just getting it set up.
So this is like the variables converted to the right units, and this is the problem.
Got it.
Okay, erase this. Make sure you're in degree mode again.
1 sec. Okay, good.
Way to go.
Alright. Let's do number 4.
I have a question.
Oh, sorry, Abby.
When it says, from the central maximum is M0,
No, it's asked, everything's always measured from the central maximum. In this one, it's asking for the first order, so m is 1.
okay.
Alright, so number 4 is a dark fringe one. So number 4 says the distance between 2 slits in double slit experiment is 0.0051 millimeters. What is the number 4? What is the angle between the central maximum and the second dark fringe? And the interference produced with light is 650 nanometers. So our wavelength, 650 nanometers, is equal to 6.5 times 10 to the negative 7 meters. Distance between the slits, 0.0051.
Getting smaller.
Yes.
That's not proportional, those zeros.
Millimeters.
That's pretty critical.
Alright, so we divide that by 1,000 to get 5.1 times 10 to the negative 6 meters for D. Any questions on how to get either of those? Big question here is, what is M? Second dark fringe. But what is the first?
So 1.
It's 1. Remember, for the dark fringes, it goes 0, 1, 2, 3. So for the first order one, the M is 0. So for this one, it's M equals 1. Questions about why that's 1? Alright, so we do D sine theta equals M plus 1/2 times wavelength. So we got 5.1 times 10 to the negative 6 meters times sine or angle equals 1 plus 1/2 times 6.5 times 10 to the negative 7 meters. I do get smaller as I write across the board, don't I?
Yes, sir.
I think I start out writing big and then I just have a natural tendency to write small as I go.
You get tired as you
Just start
go.
out even bigger, and then it'll end up pretty
So you know the different equation because it's a dark fringe.
Because it's a dark fringe.
Right.
What was funny about that?
Both right.
Think about
Don't rain on other people's
Yeah, I've literally slept.
What is the answer? 11.4.
Yep.
there's a giant rainbow.
Yeah, I see. I can't.
Quiet, guys. Alright,
Giant rainbow knocking everywhere. It's trying to get broad.
any questions about this one? Alright, I also have a kind of general review sheet for you guys on all the equations, but it's over the quiz tomorrow is over the 4 equation, like the 4 pages of math we did. You can have a note card to put whatever you want on. You can put equations, you can put, the like concave is positive, convex is negative on there. And I'd even let you put an example problem on there if you want. Ellie?
A note.
Yes, a note card, front and back if you want.
I feel like I thought that this was loose limits, but I feel like you're restricting me more. I like a couple because I like each concept.
Guys, if you want to basically you can't use your notes, so write something out. Does that make sense? If you put it on a sheet of paper, that's fine.
We can write our notes just on the
Right.
piece of paper.
No, okay.
Because I heard
Ellie's
I heard, like,
guiding questions.
no, but before I heard someone said you can do whatever, write all the practice problems on note cards, and now you said no.
Are you
So-
gonna write all the practice problems?
I thought that's what we were supposed to do. So yeah, I was gonna.
I said, what I would say you can do is whatever you want, or just most of the note cards should be most of what you have down should be the equations and stuff like that. If you want to write an example of a problem that you'd have trouble with, I'd be okay with that. I don't want you to write out the entire
Okay, I won't
everything
write
we've
the
done.
entire.
Whole book.
Ellie, just copy the worksheet and paste over.
Is there a multiple choice?
There is no multiple choice or true false on this. It's just the math.
How many problems?
It's gonna be 5.
That's it?
I
Alright.
would really like to.
I also have.
Wait, there are true false or no?
There's no true false.
Wait, it's just 5 now.
Yeah, 5. 5.
5 of them?
5.
5 math
Yeah.
problems.
Okay. I have some other practice questions for you guys if you want with answers. So you don't have to do them, but if you're looking for something else.
Have a good day.
Last